What?
They're obvious, aren't they?
I thought so, but sometimes not.
You're not done with it?
Sometimes the obvious thing is not the obvious thing.
4 slides.
If you break that cord, child, you're buying me a new one.
I'll buy 3 of them if you want.
Yeah, whatever.
She's up with that $13.50 at Farm. Indeed.
What?
Orange Friday. Well, you swear every day is Orange Friday. Every Friday is Orange Friday. For real? No. Then why
No, it's not Orange Friday. It's Balloon Pop Sunday or Saturday this week.
Wait, it's not even Friday today.
It's Thursday.
Yeah, I did. What the hell?
Hey. We've already had this discussion. You're not stupid. You're not dumb.
I couldn't
Stop it.
I feel like you stop lying to her. I feel like that's a joke. I don't get stupid and dumb.
It's not a joke. She's not dumb. Why would she say she's dumb? See, I confuse people by being nice once in a while.
Yeah, well,
It throws people all off their game.
Hi, Najma. You read really good. This is an X
Yeah, your
squared.
reading is pretty good.
This is an X squared. Oh, yeah, it is. I'm so nervous.
Oh, you got it.
No, I scored 2, but then I didn't. So then it's.
There you go.
Who's gonna?
Yeah.
What? Yeah, who's gonna?
Ma'am, let me know.
Oh, hey.
Let me know.
That's fine. That's why we got pieces.
No, I figured you weren't going to do anything about it, so.
Oh, you're right. What is this one? Because it's gonna like roll up in it. That's what we learned yesterday. But for now, I didn't understand. That's basically like. Baptism is a different. I think you can tell. Because Baptist are different. Read it. I'm gonna fail. I do not understand. Don't say that. We don't need that. I know.
Good morning, ladies and gentlemen. How are we doing today?
Better than yesterday.
Why is that? What was wrong with yesterday?
Because yesterday was yesterday.
Yesterday was today's tomorrow.
Yeah.
All righty, ladies and gentlemen. Take out your yellow sheets that I gave you the other day. Take out your headphones. Put away your phones. Let's get going, ladies and gentlemen. Okay, 4, 5, 6, 7, 8, 9, 10, 11,
Wait, I put the 3 X up here? Yeah. Not 3, but I said, affirmative action. That looks good. You know, we didn't
What? The minus and exit.
And then, I have it right in the
Like 10.
All right, ladies, gentlemen, children of all ages, anybody else not covered in the opening statement, please listen up. By next week, Wednesday, you need this yellow sheet completely filled out. Okay? Now, I did not explain everything that you need to do on this, so let's go through and let's talk about this, ladies and gentlemen. So on the first page, ladies and gentlemen, is a list of all of the compounds that are in each set. So eventually, under A, B, C, and D, you are going to write the formulas for one of those 4 compounds that is in set A. So A, B, C, and D are sodium chloride, potassium chromate, silver nitrate, and sodium nitrate. So when you go out to the station that will be set up in the back of the room, ladies and gentlemen, and you go to station 1, there will be 4 bottles there labeled A, B, C, and D. Your job is to figure out which of those 4 compounds is in each bottle. But down here, when you put your answers, ladies and gentlemen, under A, B, C, and D, you are going to write the formulas for them. And if you write an incorrect formula, you will lose half a point. Okay? So, you need to make sure you are doing that correct. Scoring. Each identification is worth 1 point. Half a point for the correct compound. So if you put down sodium chloride in the right spot, but you do the compound incorrectly, you will lose a half a point only. Okay? So that is what you are doing in each one of those, ladies and gentlemen. Okay? So, how will you know which one is which? Well, some of you may be able to go up to and identify simply looking at them. Oh, that's a yellow solution. That's got to be a chromate. Oh, that's silver nitrate because look at what it did to the bottle. Oh, that bottle has copper in it, or that bottle has cobalt in it, or that bottle has something in it that has a certain color that will identify it. So some of them you're literally going to be able to walk up to the station and put them down. Some of them you may be like, all right, R or T has to be this compound because they are both pink. M and L are both blue, so they have to be this compound. Now, you'll still have to figure out which one is which, but that's what you'll be doing. Okay? Now, on the back of the first page, it says balanced equation. Use the boxes below to write 4 different balanced chemical equations from the 17 precipitates formed in this lab activity. Each formula must come from one of the 6 sets and be completely balanced with states of matter and indicate the precipitate form. So you are going to write 4 balanced equations there. Now, in the first set, there will be 2 precipitates formed. You could take one of those 2 equations and write it there. Now, when we are doing the part here, we're not writing a balanced equation. We're figuring out which one precipitates. I will show you today what I mean by writing a balanced equation. Now, 2 rules for this. One rule, you have to take an equation from different sets. So you can't do the 2 from set 1 and 2 from set 2 and be done. I don't care if you use set 1, 2, 3, and 4. I don't care if you use 1, 2, 5, and 6. But they have to be from 4 different sets. And they cannot be the exact same 2 equations. So if the same reaction occurs in 2 different sets, which is possible, you cannot use those same 2 equations here. The equations need to be different. Okay? This part here, with the predictions and then the table down below, I'm not even going to check that. I'm not even going to check that. But I don't think there's any way you can identify them without doing the predictions. Okay? But this is your work to be able to tell me what's in model A, what's in model B, what's in model C, what's in model D. Okay? Questions? Grading expectations. Please go to the last page, please. You will need to complete the table on page 1 with all the unknown samples correctly identified. For each formula and for the compound written correctly. Boy, that doesn't sound right unless I'm not reading it right. With all unknown samples correctly identified and each formula for the compound written correctly. You will need to write 4 balanced chemical equations from any of the 6 sets of reactions tested. Each reaction must have the correct formula, meaning NaCl is NaCl written correctly, aqueous by it, a number out in front if it needs to be balanced. Okay? Each reaction must be balanced and indicate which compound is aqueous or a precipitate. Now, if they are both aqueous, I don't want you writing that as a balanced equation because that is no reaction. So it has to be one of the ones that precipitates. If all of the above is done, you will be graded with a 100%. For any balanced equation that is not done correctly, you will lose 5% on your grade. So if you don't do any of them, the best you can get is an 80%. If you do one wrong, the best you can get is a 95%. If you do two wrong, the best you can get is a 90. Now these can be all done ahead of time. Okay? If or when you identify a substance, for every 3 incorrect identifications, that means 3 full points. Either you put something in the wrong spot, or you write a wrong formula. Remember, you write a wrong formula, you lose a half a point. You don't put it in the right spot, you lose another half a point. If you lose a total of 3 points, your grade will go down 5%. So, as long as you don't miss more than 3, and as long as you write your 4 equations, you're going to get 100%. If you don't write your 4 equations, you're going to start out at an 80. Then if you put things in the wrong places, you're going to lose points. Now, the only way you will lose a full point on the first page is if you put it in the wrong place and you write the formula incorrectly. Then you will lose 1 full point. If you lose 3 full points, your grade goes down 5%. Questions? Okay. By the way, this needs to be turned in on the day of the final, before you leave class at 9 o'clock. Okay? Question? Okay. So, what I would like to do today, ladies and gentlemen, is again kind of show you what to do with a sample set. We're going to go through the part that you're going to work on today. On Monday, we will go through testing this sample set. Okay? So on Monday, we will go through testing this sample set. But for today, we're just going to go and we're going to try to fill this out. Now, I should have done this with you yesterday, ladies and gentlemen, but I did not. Don't ask me why, but I didn't. Okay? So here we go. I can't use that. I can't use that. Oh, by the way, this is the sheet that will be out there on the day of the lab. And I have them up here, so if you want to take one today while you are working on things, you can. But in set 1, there are 2 precipitates that you are going to find. In set 2, there are 3. In set 3, there are 6. 2 and 4, 2 and 5, 2 and 6 for a total of 17. So just to remind you how many are in each set. This is what I talked to you about yesterday. If there is chromate in one of the bottles, ladies and gentlemen, you will know it because it will be a yellow color. And by the way, I will not put chromate with copper to where you have a blue and a yellow color in the same bottle to make green. Not going to happen. Okay? If your bottle has cobalt in it, it will be pink. But if you look at set number 6, or set number 4, I'm sorry. There is cobalt in there, but it's in 2 bottles. So it's not as easy as going, okay, that bottle is the cobalt one, because there are 2 bottles that are going to be pink in set number 4. There are 2 bottles that are going to be blue in set number 5. Okay? You do not have to write this down. This will be out there for you, just so you are aware. If there is iron in there, it will be an orange-brown color. Again, if there's no iron in your set, don't be looking for this orange-brown color. If there's no iron compound there, you're not going to see it. AgNO3, that's the stuff that the bottle is gray or silvery. Here are 2 bottles that both have AgNO3 in them. They always look this way, ladies and gentlemen. Always. Okay? Acetate, you're going to have to smell the bottles. You're going to have to smell the solution. You're going to have to open it up. You're going to have to put it under your nose, and you're going to have to smell it. Now, last trimester, a bunch of my students were like, well, 2 of the bottles smell like it. Well, did you mix up the caps? Maybe. Well, then you're going to have 2 bottles that smell like it. Sorry, that's your fault. Okay? So hopefully you guys will not have that problem. By the way, because some of these things will precipitate when mixed together, if you take the cap off of one bottle and put it onto another, you may contaminate the whole sample. Please don't do that. So when you are using these, you take the top off, you dispense them, you put the top back on, you put it away. Okay? I will remind you of that. So those are the ones that are for the different substances, different ions there. Precipitates are what you form on the tray, on the glass tray when you mix the two things together. If you are expecting to find silver chromate, it will be easy to identify because it will be a blood red color. If you are expecting to find chloride precipitates, those are normally a milky white color. If you are expecting to find an iodine precipitate or an iodide precipitate, that will be a bright yellow color. And if you ever were to make cobalt hydroxide, that would turn out to be blue in color, which is kind of weird because what color is cobalt? Pink. So it's going to turn blue when you put it with that hydroxide. Questions? Okay. You okay? It's all right. I know we're getting near the end, but you're going to see me again next try. It's okay. All right, good. Here we go. Hey, I heard that, Meryl. Okay. Well, he's entitled to his opinion no matter how wrong it may be.
Why do you always say that?
Because it's true.
Because he thinks that he's hilarious.
I do not. I just think I'm really funny. All right.
You weren't there, you should be eating up. She was so proud of us, like, actually, yeah, that's crazy. I don't know if it was gonna be
Okay. So here is our table, ladies and gentlemen. This is my sample table. Now, what colors would you expect to see in this table, ladies and gentlemen? Pink and blue, and what else? And that gray colored bottle that you're looking at up there. There are two copper solutions, copper chloride and copper nitrate. Those would be blue. There would be two pink solutions, cobalt chloride and cobalt nitrate. And there will be one that is the dark gray. So here is what you would find sitting out at your station for you. Now, we would know that these two have to be the cobalt. These two have to be the copper. We don't know which is which, though. And there's no way of knowing it based on just looking at them. We have limited it down, but again, we have no way of knowing it. We do know this one, though, right? We do know this one. And by the way, it would be number 8. Sorry. Would be number 8. Okay? So we would be able to identify that one right away. Okay? Now, one of the first things that you should do with these, ladies and gentlemen, is write the formulas for them below the names. So copper 2 chloride. What's the formula for copper 2 chloride? Don't everybody shout it out all at once. Sorry. Cu. Oops, sorry. CuCl2. Now, you can do it on both sides if you'd like, or on one, I don't care, but it would be a good idea to write down the formula. How about cobalt 2 chloride? What would the formula be? CoCl2. CoCl2. Silver nitrate. AgNO3. All right, copper nitrate. CuNO3 2. CuNO3 2. Ladies, save it for a few minutes, okay? Okay. Cobalt nitrate. CuNO3 2. CuNO3 2. All right. So, copper chloride and cobalt chloride, what will happen? Nothing. There is no reaction here. Why? They are both chlorides. If you have the same anion at the end or the same cation at the beginning, there can be no reaction. So there's no reaction here, and there is no reaction here. Doesn't even pay to switch them because you're going to get the same exact things. And if they were aqueous in the bottles in the beginning, they are going to be aqueous in the bottles or aqueous on your plate at the end. So there is no sense checking those. All right. So which one?
Cobalt on the very bottom and then silver nitrate.
Okay. So this one is going to have no reaction. Very good, because they both have nitrates. Well, so would the copper nitrate and the silver nitrate, correct? So it's a good idea to do what you're just suggesting, Jared. Go through and write down the no reaction ones. Okay? So cobalt nitrate and copper nitrate, no reaction. Okay? Cobalt chloride and cobalt nitrate, no reaction. They both have cobalt in them, correct? Am I missing any others? Okay, so now I've only got these 4 to do. So if you take copper chloride and put it with silver nitrate, what are the products that you could get?
Silver chloride and copper.
You could get silver chloride and you could get copper nitrate. Now, copper nitrate is in a bunch of these, right? We know nothing ever precipitates with a nitrate. Does silver chloride precipitate?
Yes.
Yeah. So I'm going to circle this one because that's one of my precipitates. All right. Cobalt chloride, or I'm sorry, copper chloride and cobalt nitrate. What would I get? What's that? Copper nitrate and cobalt chloride. Okay, will copper nitrate precipitate? No, again, it's with nitrate. We know nothing does. How about cobalt chloride? If you're not sure, you should be going to this sheet, ladies and gentlemen. Looking up chlorine. Chlorine will precipitate with 3 things. What are they? Is it with silver, lead, or mercury? No reaction there. Cobalt chloride and silver nitrate. What am I going to get? Cobalt nitrate and what? Well, if silver chloride precipitated here, what's it going to do here? And what will cobalt nitrate do? Nothing. By the way, once you find a precipitate, the other one will not. The other one will not. You're not going to get 2 precipitates in the same box. That is not going to happen. So now we got cobalt chloride and we got copper nitrate. What do we get? Cobalt nitrate and copper chloride. Neither one of which will precipitate. So you're only going to find 2 precipitates here. But what is going to precipitate? Silver nitrate and what? And cobalt chloride. and silver nitrate and copper chloride. Well, I know which one silver nitrate is, right? So it should react with one of the blue ones, and it should react with one of the pink ones. That's how you're going to identify it. One of those will not react, okay? One of those will not react. Cobalt chloride will have one reaction. One, right here. Copper chloride will have one reaction, right here. Silver nitrate will have two reactions, here and here. That's it. Copper nitrate will have how many reactions? None. And the way I'm looking at this, ladies and gentlemen, the way I'm looking at this is this. I go across till I hit the X and then I go down. That means this stuff is going to have one reaction. One. For cobalt chloride, I go across till I hit the X and then I go down. This stuff will have one reaction. One here, one here. The silver nitrate will have two, but I already know what silver nitrate is. I identified it by the color. For the copper nitrate, it will have zero reactions. And for the cobalt nitrate, it will have zero reactions. So sometimes, ladies and gentlemen, you're able to identify something by what it reacts with, because we may know that. Sometimes you are able to identify it by how many reactions it has. Maybe something will have two reactions in the set. Something will only have one. You need to look at this as kind of a puzzle. How am I going to identify things? But what you need to work on today, and what I'm going to give you time for, is to do this part to all 6 sets. To find the 2 precipitates in the first, the 3 in the second, the 6 in the third, the 2, 2 in the 2. I do want to do one more thing before I turn you loose, and that is this, ladies and gentlemen. In here, in here, we have 2 reactions, silver nitrate and copper chloride, or silver nitrate and cobalt chloride. So if I were to do my balanced equations for this set, copper nitrate plus, nope, sorry, my bad. That I didn't want to do. So copper chloride aqueous plus silver nitrate aqueous produces copper nitrate aqueous plus silver chloride precipitate. Now I need to go through and balance it. When you balance it, ladies and gentlemen, and you put your numbers out in front here, these are what you're going to write on that second page. 4 of these, okay? You need to include the AQ. You need to include the AQ. You need to include the S for the precipitate. You need to write these equations correctly. Up in here, it doesn't matter if you get them correctly. You should still be able to figure out if they precipitate or not. Down here, you have to get them correct. And then you would have to balance this. This is not balanced. There's 2 chlorines here. There's only 1 over here. You would have to balance this. That's what goes on the second page, ladies and gentlemen. Questions? Okay, go to work. Go to work, go to work, go to work. If you have questions, call me over, ladies and gentlemen. Otherwise, go to work.